We know already that SIP user agents come in different forms: hard desk phones, mobile devices, tablets, set-top boxes, and of course soft phones on a laptop or PC. Now, these soft clients are great. I use them all the time. But you need a purpose to use them, else you won't bother with all the steps to set things up. Choosing a client, locating and downloading the installer, executing the installer, setting up an account with the provider, and maybe even purchasing a subscription, configuring the client, and then registering with a registrar. All things that need to be done before making and receiving proper SIP calls. But think for a moment about business to consumer environments where it's through the browser that we conduct much of our business. Shopping, paying bills, buying tickets, banking, and so on. Now, they all offer a degree of support, perhaps text-based chat or phone numbers that we can dial to speak to an agent. But in our world of convenience, well, neither of these are particularly one-click convenient. Now, it would be great for business if users could literally click to talk direct from the browser. Simply click and talk. The browser using the computer's mic and speaker to capture and play audio. No download, no installer, no account, no configuration, no registration, and no number to dial. Simply click to be connected. Well, we can, using Web RTC, Web Real-Time Communications. In this lesson, we'll look in principle at Web RTC and how it offers instant real-time IP communications direct from the browser with no download and no setup. And we'll see how Web RTC and SIP clients can interoperate. Now, the browser is not a SIP client. It doesn't understand SIP, so doesn't inherently know how to send or receive a SIP invite or a 200 OK. But it does inherently understand Web RTC, an API defined by the World Wide Web Consortium to enable browser-to-browser real-time voice and video chat. Through API method calls, browser applications exchange Web RTC offers and answers to establish peer-to-peer media sessions, accessing the host's resources, the mic, speaker and camera, to capture, stream and play audio and video right there from the browser. So, how does a Web RTC browser client connect to a SIP agent in an enterprise call center? Well, through a Web RTC gateway, an advanced SIP service with additional Web RTC capability built in. It's a SIP client on one side and a Web RTC client on the other. Its purpose is to translate between the two. So imagine I want to ask a question about my bank balance. So I click to speak and immediately a Web RTC offer is created, pre-populated by the application with routing data that takes the offer to the gateway. In turn, the gateway creates an equivalent SIP invite and sends it not to a phone, but probably to another advanced SIP server, a call center application that manages and distributes calls between the agents. The normal SIP exchange ensues, the gateway acting as a SIP endpoint, translating the 200 OK to the equivalent Web RTC answer. Now, Web RTC uses a session description protocol very similar to SDP, one that details available codecs and where to send and receive media packets. Now, if both SIP and Web RTC clients have common codecs, and they should by default have at least the G711 codec for audio, and if they're on the same network, a media session will be established between the two endpoints and media packets exchanged direct between SIP phone and browser. Now, it gets a little more complex than this in most scenarios for a number of reasons. The need for network security typically adds another layer. Where the client's out on the public internet, there'll most likely be border controllers protecting the enterprise network, firewalls, session border controllers, reverse proxies, and so on, meaning that in reality the media streams will also traverse some kind of edge device border controller. In all probability, the call center application will be a back-to-back user agent, and there's a good chance it will first connect the web client with a media server. perhaps to get a PIN number or perhaps to play music whilst waiting for an agent. Web RTC is designed for real-time video just as much as for audio, meaning that web applications could include click-to-video in its interface, enabling one-click live video chat. But, as is the case with audio, both clients, SIP and web, must have a common video codec. Currently, the website tend to use the VP range of video codecs, VP8, VP9, avoiding the H.264 codec typically used by SIP phones due to license restrictions. VP8 and VP9 are free, whereas H.264 needs licensing. Without compatible codecs, there will of course be no video. The solution then is to pass the video streams through a media broker that transcodes between H.264 and VP8 encoded video streams. Some media brokers have lots of other useful capabilities, like being able to modify streams for mobile clients that have smaller screens and less processing power. They might apply scalable video coding, SVCs, sending perhaps subsets of the main stream to the different endpoints depending on their capability. Web RTC can of course be used for all types of communication, not just business to consumer. Imagine a conference service and Nathan and Alice are in a video call. A meeting invite to Dave could easily include a link, which, when clicked, joins Dave straight into the conference, direct from the browser. There's great potential for use of Web RTC to supplement the SIP network. Okay, that's Web RTC, Web Real-Time Communications. It's a worldwide web consortium standard for browser applications to communicate peer-to-peer, real-time. It's more than a signaling protocol, but includes methods through which media sessions are established. The huge benefit of Web RTC is convenience. No special software to download and install, no account to set up, and no number to dial. The web application uses the host computer's microphone, speaker, and camera to capture and play back media streams. Web RTC and SIP interoperate through a Web RTC SIP gateway that translates between the two. Although audio streams could go direct between the Web RTC client and the SIP phone, it's more likely that signaling and media will go through some kind of border controller, perhaps a firewall, session border controller, or reverse proxy. Web RTC inherently offers both audio and video, although in SIP calls, video streams will probably need transcoding due to incompatible video codecs, the web world typically opting for the free VP8 or VP9 codecs, whilst SIP phones typically use H.264.